Hey, sorry.
Hello, this is the MOSFET emitter.
Common drain source. What was it? I don't know.
Common drain.
Hey, I see drain. I see
The
drain.
drain
I see drain.
is not being used, right? So it's a common drain. So is the gain
Steady.
non-inverting? Inverting? Is the gain
And
very high?
yes. Drain.
So this is a source follower, just like in the BJT case as an emitter follower, or a common collector, or in this case, common drain. Okay, the gain, okay, is non-inverting. That means it has the same phase. Okay, and the gain is always lesser than 1. Always lesser than 1. At the most it can go is 1, but it will never be 1 because there will always be a source resistance. So it will never be 1, but it's always smaller than 1 and it's always positive. Right? So for instance, when this voltage at the gate increase, okay, then what would happen? The VGS will increase, and obviously the current will increase. So when the current increases, the current will go through this resistor, causing this voltage to go up. So when the input goes up, the output goes up. So it is non-inverting. Okay, so that's how you look at it. Now this particular example has the gate connected to the source. And because of this connection, it is known as bootstrapping. Okay, what it does is that when the voltage at the gate goes up, because of this resistor, it also pulls up the gate, the source voltage. So it's like lifting the source together with the gate. They call it bootstrapping. What is bootstrapping? Bootstrapping is when, in the old days, the Western, they wear cowboy boots, right? And they will strap their gun belt to the boots. The bootstrap it so that the boots, because the boots is long, it will fall, right? So the bootstrap is to pull the boots up so that the boots, the top end of the boots doesn't fall. So that's what we call bootstrapping. Okay, so here we are given GM and we are neglecting R0. So we can draw this as this. So this is your question 3 of tutorial 8. Okay, we have this transistor here. Okay, and we have this resistor that is bootstrapping the source. Okay, and there's a source connected to the load. We are given that GM is 3.54 millisiemens, okay, and R0 is infinite because it's neglected. Okay, we are also given RG is 1 meg, and RS is 2K, RL is 100K.
Hey, Rob, cannot see your.
Oh, so sorry.
Thank you.
Okay, and we are also given that VDD and VSS is 10 volt.
Salam, Salam over here. Salam.
We asked to find out the rate, the gain, R in and R out, and also what happened if R in is exactly equal to 1. Okay, so this is what we are given. So here we are given this. So in in AC equivalent, we can draw this as this. Okay. And so you can see that the gate is connected to the source through this huge resistor, which is 1 mech. Okay, so this is 1 mech. This is 2K. This is 100K. Okay, so we can write the equation by summing the current at this node, that the current coming from the input to the source, the current that is going from VGS, GM-VGS, going upwards to the source from the drain, which is down, okay, and V out, which is across these two resistors in parallel. So all this can be summed into this, okay, and therefore we can write that VI, okay, minus V out divided by RG is the current that's flowing through this branch, okay, plus the current that's flowing through this, which is GM-VGS, okay, is equal to V out, okay, divided by these two resistors in parallel. Okay, and therefore we can also write this as, so GM, VGS is the voltage at the gate minus the voltage at the source. But the voltage at the gate happens to be VI, the voltage at the source happens to be V out, and therefore everything is now in V out and VI. Okay, and therefore we can now substitute the value that VI minus V out divided by 1 mech, okay, plus 3.54
I think almost everything is for you.
milli, okay,
Yeah, coming soon. End of the year.
the difference
Then I said
between
that.
VI and V out is equal to V out over
I have
2K
checks only.
in
I
parallel
have
with
checks. I have a few
100K.
walls. What's a goblin?
Okay.
Goblin builder. This one you pay extra gem, right?
And therefore you can also write
You
this
get a
as
7
V out
builder.
divided by
But you need to pay
1960
You see something?
because it's closer to 2K than
Yeah, 1 hour,
100K.
1 day,
And
right?
therefore,
This goblin,
by
right?
doing this,
So 3
you
gem,
can
I will upgrade for you. But it's 7. There's an extra one, but it's fucking expensive. 1 day, $40. 40 gems. But I need already, because I got here, right? By the time, like, I'll max out everything right before 2017, so got yeah, 1 max. Yeah, bro. All in all, is the most much one. I left 9 walls, I got some walls, haven't maxed it. 1 more than
therefore V out is equal to
7 attacks for 1.
0.874 VI.
1 attack, get 1 million. Crazy. Yeah, now the
You're shocked. That is
it's not my
below what we
it's not
thought.
decrease a lot.
That shock, I don't believe it.
Okay, not too bad. I don't know.
So the overall thing is basically
take all these gems, right?
lesser than 1.
Okay, not too bad. Just attack more.
Okay, and if we want to find out R in, okay, R in is basically VI divided by II. Okay, and that happens to be VI divided by
go higher
VI
higher
minus
leads you
V
get more
out
or
divided by the 1
this
mech.
one is to upgrade your equipment. Yeah,
Okay,
very
and
important.
therefore now we have
You only can get all right from
bring the
higher
1 mech
from
up.
daily attack. at higher leagues.
Okay,
And,
you have
can walk.
VI here.
So not everyone is
And
at
below you
least
have
Titan.
VI.
Hope I don't give you the most.
V out now, you
Okay,
can write
not
it
bad.
in terms of VI.
Someone inside my clan. Brian also. Wait, let me see.
And you can
Have
cancel
an
all the
actually.
VI.
You can just join.
and
You
end
wanna
up
join?
with
Just join.
This
You add me first.
over
Wait,
this.
I can send you.
And if you work this out, it's
Just
7.94.
copy this tag. Wait, I'll send you. I'll send you the.
So if you look at this, you can see why we just mentioned that the input is being bootstrapped.
How's the report you do?
If you look at the entire resistor chain here, this is 1 meg, this is 2K. So if you look
Oh no,
in this direction,
Actually, I plan to take
what
over
you
the-
see is
just now
basically
I took over the leader.
1 meg
When I joined
in
last
series
year,
with
I was
2K,
already here.
and the
I was
2K is in
like,
parallel with
I did over
100K.
2 today.
All
Because of
in,
steps.
it will
Yeah,
never,
like-
it will never add up to 7.94 meg, and
The
yet,
co-leader is my
because
NS,
of this configuration,
my what?
the actual
Senior.
input resistance has been bootstrapped to a value that is so much bigger than the actual value of resistor that is being put in together. Right? So this is what bootstrapping is all about. It means that when the signal here goes up, this signal also goes up, which in turn push this two voltage, or rather the voltage across this resistor a bit escalated, causing the resistance seen at this point to be a lot higher. Okay, so that's why this is called bootstrapping. Okay, then the next part of the question is that
Whenever I only buy the gold
we have
mask.
to
Oh, I
find
got buy
out
one skin out of Harlan one.
okay, and then after
I don't
that,
even use it that much.
the
actually. I don't like
the
it.
gain, if
Damn shit bro.
the gain is equal to 1.
Oh, this one is a free one. That time you give us free. Good, yeah. Very nice. You got animation. Oh, this one is my favorite. Oh, all
So
the
if you want to find out the output resistance, we kill the input source, we kill the input source, and evaluate the resistance looking into the this node. Okay?
Oh, then the shield is spinner.
Wait, there's no difference.
I know.
Kill the input
I need buy one
source.
cannon.
Then different.
Your 1 meg resistor is still here. Your current source here, VGS, is still here.
But he
Okay.
doesn't have C.
Your RS is still here.
What's better
And
than
now you put in a fictitious voltage source, VS,
same.
and measure the current going in, IX, to find out your output resistance, R out.
That's no point. Hey, I'm expecting you to
Okay?
study already.
So there's your
Oh, then okay.
VS.
Yeah, I used it for quite a while.
So again, if you look at this is your gate voltage, this is your source, this is your gate, okay? And voltage at the fictitious voltage source that you put in here, Vx, is actually equal to Vs, alright? And therefore we can write that Vgs, small vgs, is equal to minus Vx, alright? Because Vgs is Vg minus Vs. If Vg is 0, Vs will be the same as Vx, okay? And therefore we have this, okay? And we can now write the equation Ix, which is the current going in from the source Vx, is equal to Vx, okay, divided by Rg, because this voltage divided by this gives you the current flowing in from source to gate, okay, plus Vx divided by Rx plus Gm Vx, okay, and therefore this is all in Vx term, so you have Vx divided by 1 meg, bless you, Vx divided by 2K plus 3.54 milli times Vx. Okay, so if you work this out, take Vx divided by Ix that will give you your output resistance,
I just gonna.
which happens to be equal to 247 ohm.
Oh shit, the wrench again.
So the output resistance of a common drain or a source follower is low, is very low. Okay.
Yeah, usually I do this. Yeah. Because I
And
hit legendary. I hit
You
legendary.
can now find out in part B,
Yeah, don't worry.
what
I
if
don't know legend. Only can
the
attack two
gain
times.
is equal to 1? Okay. So if the gain
Yeah,
is equal
not
to
fun. You
1,
can still get loot lah, but not a lot.
then we look at this. If the gain is equal to 1,
Or higher all, you're a bit more.
then we go all the
Some
way,
people like to climb
and
all
we
the
find that
ranking, the legend ranking.
R in will be infinity, because what would happen is that VI and V out will be the same. Okay? When VI and V out is the same, this term becomes 0. Whatever is divided by 0
Then shot.
is infinity. So if we look back at R in is equal to VI over VI minus V out over 1 mag.
Yeah.
And
you
if
shoot one, like,
VI is equal to V naught, then this term becomes infinity. Because this bottom is 0. Okay? So the denominator is 0, and therefore the input resistance becomes infinite. Okay?
much
Any
easier
question?
with the equipment.
No, I didn't bring the tutorial.
Defense, defense, because not that easier, then we have to defend. On 3-star. Now everyone 3-star everything.
Die. How?
What is it?
I seem signing for my iPad. Limited.
Sorry?
Oh, what did
Oh, just now, I never see.
you have
I want
read?
to spin. Oh yeah, close. Let's go. Last one, right? Firepower.
But before that, let's collect. Should I collect?
No way.
How much?
What? Please, no.
Yeah, I think it's about
Okay.
now it's 12, 13, 14.
Funny, bro.
Did we collect the link?
Yeah. Yeah, bro. Because I never even like plan. I don't even have barbarian kings. Yeah.
Assignment is supposed to be 1 week after the break, right? Anyway, we can start collecting first. Then we will talk about the next tutorial. You want to any assignment?
Oh my, then plus poison. That's painful. That pain. But then luckily I don't turn out to be usually whenever before the time I only turn out to 10 or something.
I got it. What keyword?
Need write what? Need write what? Need write what?
Okay, that's why I passed.
Oh, I don't want it.
Never give me a right.
Frequency response.
Never give you a right from your home. Never give me a right from your home.
Right.
I won't let you.
I need my cigarette, bro. Today got CC
Don't have, bro.
Addicted, bro, addicted. Want to have Oh, yeah, no need to come here. Oh, hey, you time you listen to one people. Only one to one.
She changed it.
But it's one to one, right? Oh, shit, bro. Yeah, I also Viva, you only present Yeah, first. I prepare. I on the spot. Like before my visa, I prepare. Are you traumatized with my sister?
You got good choice.
Yeah, but I can.
Okay, so the next part of this happens to be frequency
Second brother,
response.
one is 1-to-1 only.
Okay, so this is where we make use of capacitor and inductor together with the resistor to make some kind of filter. Okay, so here in tutorial 9, first question, they are given this transfer function. So what do you mean by a transfer function? Transfer function is normally a measure of gain. Okay, output versus input. Okay, so you inject a certain input and you see the response at the output. So here we are given this transfer function, and in this transfer function you have on the top, actually you get a gain. Okay, this is your DC gain, 10 to the power of 12 is your DC gain, and it has 2 zeros on top, S squared, and 3 poles below. So what is the difference? What is zeros and poles? So zeros, okay, as frequency increase, the zero will help to increase the gain. Okay, so as you can see, S is a Laplace for equivalent to j omega. Okay, so when frequency increases, S actually increases because it's representing frequency. So when S increases, the overall transfer function actually increases. So 0, which is always on top, help to increase the gain.
I only read 7.
Poles, on the other hand, is at the denominator. Okay? When poles increase, the gain drops because the overall gain starts to decrease, right? Okay, so as pole increases, the denominator starts to increase. So therefore, the overall transfer function starts to decrease. So therefore, in frequency, zeros help to increase the gain with frequency. Poles help to decrease the gain, the overall gain. So here, if we have to plot this, versus frequency, we want to plot the gain, in this case the transfer function, versus the frequency S. Then how do we go about doing it?
I just finished 7.
So we first say, okay, let's say what happened when S is equal to 1.
Oh no, it's just some random ass interest photo.
Okay, then T will be when S is equal to 1. Okay, then that gives you 10 to the power of 12 because 1 times 1 is 1. Okay, then we look at this 1 plus 10. You say it's 11. But here, I say it's 10. Because 10 is so much bigger than 1 in terms of it's 1 decade away. Alright? So we say that it's 10. This is by approximation. Alright? So it's going to be 10. And obviously, 1 compared to 1K is 1K. 1K compared to 1 meg is 1 meg. And therefore, here we have 100. Correct? So 100 in dB is
No, I scared wrong because my voice fucked up already. 10 12.
how do you convert numerical gain to dB? 20 log 100. Okay, so this is equivalent to 20 log
No, no,
100,
it's not times
and you will get 40 dB. Okay, so now what? When I'm at 1,
1% started doing energy.
I'm at 40 dB. Okay? Then, I make S is equal to 10. Okay? Then the numerator becomes 10 to the 14. Alright? 10 to the 12 times 10 times 10. Okay? So it's 10 to the 14. Below, miraculously, when you say 10 plus 10, you get 10. So in magnitude term, why is it so? Because in magnitude you have s squared plus 10 squared, and you square root it.
Part 3 will be linked to part 2.
Okay, so you have 2 times 10 squared.
Yeah, part 3. The frequency
So
response.
2 compared to
yeah.
is nothing.
Where is
Alright,
linked to the
so
MOSFET
therefore,
BJT
if
chapter?
square root of
So,
10 square is 10. So you back to 10 again. Okay? Then you come to this term. 10 plus 1k is still 1k. Okay? 10 plus 1 meg is still 1 meg. So now we are up at 10 to the 4, which is
Yeah, I know. I got handwrite.
10,000.
Yeah, I tried.
Okay? Which means that this is
What's the video help me?
The video.
80
You only
dB.
go through the example a bit more in depth on this.
Okay? So
You go see the video.
we go to here, we are at
Or do the
80
tutorial
dB.
sheet.
It is in dB.
Okay.
Okay? So
You
this
read the
is
slides. I think more than
10. Okay? So we here, over here,
不一样。
Same bro.
at 10, we are at 80 dB.
What?
So you can see this.
Chấm là
This is 1 decade. From 1 to 10 is 1
So
decade.
your signals and
And the difference is 40 meg.
Like that we
it doesn't.
So this slope
What matters is final.
is 40 dB
actually I feel like midterm more important. Sir.
per decade.
Like, you know my EDM right? My EDM I only do 1.5 question. Third time I sick. I find out I sick. Okay, still get B plus. Not bad. I think it's a midterm. Midterm so.
Small.
Thomas.
Then we go to the next one.
Oh. 0 is the left side. No. I never read.
Okay? So this here now becomes
Oh, EDM midterm I do I only get 50% for
50.
then it's 0.
Yeah. No. Then my EDM right, I find I 6 3 before.
Then
I never studied the last.
Now I
I
have
do
1K,
What's the rule?
or rather
First question I think I
1K
wrong,
here,
then
10
it's
here,
just
so it's
B plus
1K.
Yeah.
Okay?
How's the idiom?
1K plus 1K, also 1K. Okay?
I need to
1K
how to do
plus 1 meg
the last
is
chapter.
1 meg.
I never read. Okay, bro, I just skip.
So now this
Oh,
is
but I scribble something. I don't know.
10 to the 6. Okay? And if you
Yeah,
work
but
this
the
out,
question
this
here
is
is
120 dB.
I'm not question. Not whole. I think that's the half of it.
So now, from 10 to 100 is one decade. From 100 to 1K,
Yeah, miss.
it is another decade. So right now, we are at 1K, but here we are at 120.
Got one guy we know 10 years. That one is a luck man. Using what calculator?
Okay? So this tells you that over
Do
here,
RE.
we have in 1 decade, we would have gone to 100. So this slope here
Oh, but because of that, oh,
It's
this kind of question I don't
20
like. Where's the
dB
money? Because of that graph.
per decade.
Oh, yeah, it's like if
The
you
slope.
right. Like from the ABCD, right?
Because
you
in 2 decades, you have
30,
40
Then you try and
dB.
calculate it.
Alright.
Then you work backwards.
So 1
Every
decade,
question,
20
some-
dB.
some
So
question,
the rate
I
of
think
change
there's
now
one
has dropped a bit.
Yeah, just need to work behind,
Okay.
work backwards.
Then we
Teach you to
go
double
to
check answer also.
1 meg.
Yeah. Yeah.
So this becomes, we have another 6, so therefore this is 10 to the 24.
Hello. No more study now.
Okay.
Everyone will forget one.
And at the first hole, you have
Maths tonight.
1 meg, compared to 10 is still 1 meg.
Signals.
Okay.
Study, yeah.
1 meg
Signals,
compared to
oh, but
1K
I going to
is
this.
still 1
Okay.
meg.
Study high.
Tomorrow.
1 meg compared to
before
1
I
meg
just read through
is still 1 meg.
the question. Fuck it, never mind.
And
Then
therefore
cannot
here
get 8 or
is
10, never mind. I
18,
think that's
so
more
this
important.
is
Fuck it, 2. Yeah. Just give. I already
So,
you paying to study.
this
I'm
is
giving away.
1K,
You get paying to study?
10K,
Study life first.
okay,
Then
100K,
the maths I think
1 meg.
I think the maths quite thick. You studying for IRA signals?
Flat.
I told you today I watched the video.
Oh. Hey, actually I find the last part like quite tricky.
Okay,
But for
so from here
What
on,
you think about tougher? The frequencies like I see.
it will go down.
Sorry?
see the net
If there's any hole from
Proving I
here
don't care.
on, it will go down.
The proving I don't care.
Okay, so, but this is what it is.
It's like
So we will end up having 1, 2,
Oh yeah, sometimes
come to this point, okay, it will go down at a rate because of this, because there's 3 poles and, 2 zeros and 3 poles. So the net will be, there's
What I do is I read
more
the summary.
poles than
The summary
0.
usually is all the
Okay.
most important one.
So this
The summary.
would have to go down at minus 20 dB per decade. Signal processing. No,
Cigarette processing.
this is control theory.
Tobacco.
Okay, so this is what it is. So whatever we have done here is by approximation. Okay, because as you can see, 1 with 10, we say is 10. Okay, 10 with 10, we say is 10. Okay, 10 with 1K, we say is 1K. Okay, and so on. All right, so all this is going by approximation. Any question here? What happens if we don't approximate?
Yeah. Good question. Yeah, it's fine.
Okay, what happens if we don't approximate? So we don't approximate, then that's where we need to introduce all the magnitude term. Okay? So in this case, okay, we can find out at, because, so here, what is the bandwidth of this curve? What's the bandwidth of this curve? The bandwidth is here. This is your bandwidth. Okay. Why is this your bandwidth? Because this is known as a passband where the frequency can go through without attenuation. Okay, it has a fixed gain during that portion. So this portion is called the bandwidth. Okay, so when you come to the bandwidth, we need to calculate the bandwidth, and the bandwidth will be 1 meg minus 1k. Sorry. Okay, so that gives you how many zero do I have to put in here? 9 meg 9 0 no 8 no 9. What am I doing? Okay, so that's the bandwidth. So the bandwidth would be so much, okay, in radian per second. Because when we look at S, okay, S is equivalent to omega, all right? So therefore it's in radian per second. So this is your bandwidth. So when we talk about bandwidth, remember when we did op-amp, we look at the 3 dB roll-off frequency, remember? Okay, so that is at 3 dB. Why 3 dB? Because that's where it becomes 1 over root 2. Okay, if you find this gain here, right, and you take 3 dB below, okay, and you convert it, whatever value that is converted will become the gain divided by root 2. And that value is 3 dB below the maximum value. So how do we go and calculate this? So in order to calculate this, we go and find out when S is equal to 1K and when S is equal to 1 meg. Okay. So when S is equal to 1K, that is 1 point of your bandwidth, and when S is equal to 1 meg, it is the other point of the bandwidth. So we want to find out the actual value when that happened. And when you look at this is 10 to the 12. This will be 10 to the 6 divided by S squared, which now becomes 10 to the 6 plus 10 squared square root, square root of this, square root of this as well, 6, and square root of this as well, S squared, okay. Okay. So if you go and do all this calculation, this will be 10 to the 18 divided by square root of all this term. Okay, and this is 6 Okay, anyway.
Sorry.
Okay, and if you calculate all this, I don't have a calculator.
Oh, don't have.
Okay, you calculate all this, and then you 20 log it,
You can buy.
you'll find that it is approximately 117 dB.
Yeah.
Okay, you find that it is approximately 117 dB, which is 3 dB below 120 dB here. Okay, so that means to say it will drop by 3 dB. And therefore this curve will sort of taper. Okay. So similarly, if we find out T at S is equal to 1 meg, then this will become 10 to the 12 times 10 to the 12 divided by square root of 10 to the 12 square, oh, sorry, 10 to the 12, correct, already square, okay, plus this guy which is 10 to the 2, okay, multiply by 10 to the 12 again, okay, plus 10 to the 6, because it is k, 1k square, okay, times again here 10 to the 12 plus 10 to the 12. Okay, and if you go and evaluate this in dB, you find that it is again 117 dB. Okay, so that's why on both sides you have 3 dB below, and that's why this is known as your bandwidth. So the bandwidth is always 3 dB below the maximum value. Okay, the starting and the ending point of the bandwidth. Okay.
Just go through the number of
No, I do.
Any question?
What do you know?
So it's mathematics
Cruiser.
and approximation.
Oh, 6. No, 6 means you know.
So this is more straightforward instead of all the electronics,
Do we can?
where you find the,
Diode.
you know, the operating point, the GN, you know, R in, R out, and so on. This is very systematic. Any question?
No.
What's the other part of the question?
All the tournaments in the country that are
REP.
Huh? Pardon?
REP. Really?
I know one friend from TPAG,
Okay.
he got scholarship.
Yeah.
TPA,
REP, the overseas exchange is free. Overseas exchange.
he's you got 3.9 something. Poly.
I find it's too shared.
Okay, let's have a look at this. Okay.
Walk to the here. You should take a master's degree.
You stay there.
Sheng like a lot of Sheng many things. Magical IP. Yeah, we choose one of them Sheng.
Disable display
But okay, good lah.
So what is this?
Actually, I think really should.
Which master can remove
All the connection also.
Is this a low pass? Is this a high pass?
Because you connected with all the stuff.
It is a-
then you
is it a
need
low
pass
pass?
everything event all that. You need all the outside.
Or is it a all pass?
Oh yeah.
Okay, sir. So there are four possibilities.
Remember
High pass, low pass, no pass, all pass. Or
everyone minus one.
band pass. So yes. So this is a
But you
low
know
pass
something very sad.
filter.
You know something very sad. You
Why is it a
know
low
the
pass
rule of
filter?
thumb? The
At low
quiz
frequency,
questions, yeah.
okay, whatever signal here goes out,
Okay, not quiz
you can
question.
change the
Yeah,
capacitor
that's
not
why.
there. At low frequency,
here,
because
bro.
at low frequency the capacitor is
sorry.
open. Alright?
even
So
got
whatever
another question.
signal appear here, appear at the output.
Wait ah.
Okay, so that is at low frequency. you
Another
must
question is
go.
over here also.
As the frequency increase,
Yeah.
this becomes a potential
It's the same
divider.
question.
Okay? Initially, the resistance, the impedance here is very high.
Good question.
As the frequency increases, this impedance
can,
becomes
ChatGPT,
smaller and
you can-
smaller.
I mean, you
Therefore,
can
the
find out
signal
one.
strength now
That's
is potentially divided,
Understand, yeah. Very true.
where V out is equal to V in, potentially
Quiz
divided
questions, yeah.
Or you need
through
to
this.
go on after that.
Yeah. This thing.
Or in other words,
But he also didn't
V
know.
in
He got the file at the
over
start of the sem, but he never opened out the
ZC
file. So it's like,
divided by ZC plus ZR. Okay? So as frequency increase, this becomes smaller, alright? And therefore the gains start to drop when the frequency increase. In other words, V out over V in start to drop with increase in frequency. So when frequency increase, the gain drops. Okay, so it's a low pass. So in other words, if you go and plot this in terms of frequency, you will end up having this. Okay. Alternatively, if I have a capacitor and a resistor, you will then get the voltage at the output due to the voltage at the input multiplied by R over, ZR over ZR plus ZC. Okay? So as frequency increases, okay, this at low frequency, of course, there's nothing. The output has nothing. Okay? But as frequency increases, the value of V out start to increase. Okay, because this term becomes smaller and smaller. So the major portion of Vi go across R. So therefore, when frequency increase, this term, okay, start to drop. Start to increase. Okay, because the input drop across this resistor more than this, because this term becomes smaller and smaller. Okay, so the value of V in appear at the output to be stronger and stronger will
Okay, signal
increase
that is
its
everyone's same
frequency,
paper.
and therefore when you plot this,
Yeah, like, is it everyone's same paper?
Signal.
The little.
Aiyah, you lah, need change answer.
Eh, Rui-Hang, you see Rui-Hang later. You see Rui-Hang later. Rui-Hang also o'clock.
Who?
Rui-Hang.
Awkward.
Fucking awkward.
Oh, it's like after
okay,
that.
you will end up having this.
Huh?
Maybe after that then you eat mala.
So this is
No, you
your
have a
high
test. You
pass.
have a test.
Fucking awkward. Just say everything normal. 好尴尬。
I sit behind. Okay. You sit. You got pen or not? I wait for later.
Oh yeah, I got 2 pen. I got the thing for
Nice picture.
I need this one, the Sarasa. Oh yeah, I give you one. Yeah, you can have it. Yeah, give you it. I got one.
I don't want them for him.
Oh, the waiting thing. Okay, where to start here? Okay, so basically we got this guy in our group. We don't really like him. Because he like...
From the very start.
Actually from the start, I really don't like him already. But then after a while, yeah, I got tell Draven about this. At the start, when I first met him, I was doing the maths E, you know, in study at time. The 2D.
So what is this?
That's the first time I met him. Then that day you really chibai me already. Like because he asked me to explain one question, then I explain one. Then he like,
Remember in tutorial 4,
but then after
we
that
did one
next
of
time,
this.
like I'll keep him.
You still share the chat with him.
But then in tutorial 4,
So you share the
we
subscription.
were
No,
doing
the thing is
something
that he
very
asked me to share. I
ideal
thought he shared
because
with
the
you all.
op-amp is
He
ideal.
DM me because he said you're a maths group.
And
I thought the
at
chat,
that
right,
point in time, we don't
ask me,
have
then
our
we all
tool.
complete.
They never even ask us.
We don't have our tool.
Then I
So
realized
can you imagine if it is not ideal?
No, because
If you don't have
I
R2,
thought it's 1/5.
meaning
That's
that
why so expensive.
at low frequency,
I
at
thought he because
DC,
I'm not in the maths group. Then he messaged me.
then without R2,
Huh?
you only have a capacitor.
I don't like, we don't really like.
So if the capacitor is open at DC, what will this
But the check, I
amplifier
only
do?
realized when I just say, hey, you want to share the check at the start listen. That's like,
It will be open loop because there's no
No, one
feedback
line, that one
because capacitor is open. So
There's a meter.
remember, if it's not ideal, there's an offset. And what would happen to the offset?
I paid like $7 or $7. I thought it's
The
not.
offset will be
You only buy 1 month.
multiplied by the open loop gain because it's a DC,
The whole time I thought it's share with yours.
and therefore
This
the
time I remember
output
ChatGPT
will
was like
be
$30.
either be
I
a
remember
DDD
ChatGPT. I remember ChatGPT told
or
me that. So I
at
thought
minus
$7 makes sense. Like,
DDD
this is
because the offset
That's
is
always
being
half.
multiplied by the
And
gain
yeah, I
that's
never use
very
it.
large.
There's nothing to use.
So that is for
I thought physics good.
when it is not
But
ideal.
last time,
But
never-
if it is ideal, then there's no offset, no nothing, there's no problem. Okay. So here, because it's non-ideal, we have a resistor here. So with that resistor, at DC, any offset will go through
Oh, I could use a B. Yeah.
this, causing the output to be limited by the gain R2 over R1 plus 1.
I was thinking, oh,
Because the
your one is
offset,
DE, huh? Then I
you
thought, okay,
always
let's-
put
I just
it
join
at the
use it
non-inverting
for
side.
my other thing.
Alright?
So I thought
So
it's
the
wrong.
gain, the offset will be multiplied by 1 plus R2 over R1, and therefore, normally the gain is much lesser than the open loop gain.
Because
And
yeah,
therefore, the voltage at the output, the DC voltage at the output is controlled. Remember we did an op-amp when we introduce offset, and then at the end we say that without the input, the output happens to be negative, and therefore the output will swing towards the negative, it will click at the negative, and so on. So same thing. So here, the idea is to limit the offset going through the gain so that the output will not be stuck at VDD or 1. And therefore now you look at this. What is this? Is it a low pass, high pass, no pass, all pass, or what pass?
Okay.
So this is a gain,
Okay,
low pass. Okay, without the resistor you can see it is a low pass.
highest grade for every system.
Why is it a low pass?
Let me show my CC3 poster the feedback.
They have the X.
I'll show you.
At low frequency, okay, the gain
I'll show you.
Enough
is
nonsense.
Yeah,
huge.
I'll show you again.
Okay, because this is a resistor that is very large,
Who's your professor?
okay? So therefore the gain is large, okay? As frequency increase,
what are you
the
talking about,
impedance
bro?
between the input and output through this path becomes smaller and smaller, and therefore the gain becomes smaller and smaller, and therefore
I went down on my
in
disc.
this particular case, you would have this.
Kan on Telegram mah.
Okay, so your gain is gonna look
I'll put
in
notes
this
so I can
manner.
save it.
So it allows low
At least I can view it
frequency
next
to
time.
pass and drop high frequency. Okay.
You see all the components. You see, cause means I got that thing. Here, is it here?
This is his comment.
Dia ada X
Then
X.
X is the one that I scored.
This is
I scored the X.
A.
The dash one is another.
don't know whatever. So then this is the other one.
I got the best one. I don't have to wear it. Because it's a Padang one, the mid range one and the low range.
You're so humble.
Stay humble, guys.
Thanks,
Here also the next one, the highest. Like the robust, this is robust one. And the rest is like the Padang. I never get the I get the highest. This one also highest. Right.
Then?
Okay, but then see the one also same. Relative to the issue. This one is the mid range one, I get the highest.
So what about this?
The next everything out, bro.
Faster.
No, the whole thing, bro. This also max, this one also max, bro. This one also, even the fucking language max, bro. I don't know how.
That's the thing I very used to like.
The nation also easy, max. Everything max, bro.
So at low frequency,
Or the
Okay.
basic clear physics.
the signal doesn't get
Real world
in.
example, condition level.
Okay, signal doesn't get in.
Oh, you like you.
As
Bro.
frequency increase,
Heavy class C.
this impedance here starts to increase.
So humble.
It start to increase.
Stay humble, stay humble.
Sorry,
Yes.
start to increase. The impedance start
Be
to
humble is
increase.
Period.
And therefore the gain start to increase. So you will end up having this.
Euthanasia. No,
Okay.
how no,
So this gives you a high
I
pass
sit down
filter.
on my chair. I do finish then I stand up. I think it must be
Okay.
6 hours.
Serious.
Yeah, 6 hours. Bro, I don't even let go. Kena bro, you know got turn in bro, I don't dare. My CC one also, I never put check bro. You know, hand right now, hand. That's why I report. I do it myself. No ChatGPT.
You legit never use mah?
Huh? No serious, I don't dare to do it. Turn in bro, turn in got the AI checker.
Ni dan hal.
No, turn in, you AI checker like it's on the prof side one. Yeah, so I don't dare. That's why I report myself. Use my own hand right now. My own hand, my two hands. My mind bro.
You so fucking funny,
Bro, I hope it inspire you. You got submit your poster yet? Okay, I can send you my what you can inspiration. Yeah, but don't copy. Later kena. I send you. Serious. I send you. I already sent them already. So,
So in this particular case,
the reference it's a
你
model.
先，你先吧。
you will see that
Same topic.
at low frequency this is still open. Okay?
Oh yeah.
So the signal doesn't get in. So again, you will see this. And then, because of the combination of this capacitor and resistor, you will end up eventually having this.
Why is that so big?
Both high pass and low pass.
This one is the one
So
that the
it
guy
has a low pass filter here, high pass filter here. Together, this is actually a band pass filter. It has both high pass
yeah, we got
and low pass. Okay? Depending on the values of the resistor and capacitor, you can determine the 3 dB roll-off point. All these 3 dB roll-off point can be determined by the values of the capacitor and resistor.
What's the thing like?
Okay? I think we will do more of this next week.
Three, huh? Wait, your
Where
signal
I
step
can put in some values.
Where's the signal step?
And I think I will
3 seasons.
show you some
Oh.
simulation as well,
Yeah, I think you'll see him sometime.
which is
Yeah, a bit chubby. See. Oh, I see before.
He really long wait for us.
Oh, yeah. The guy, he like,
this JD started.
yeah.
Which one is he?
Yeah, too long. Until the episode.
Oh, the EE.
You might see CC. Maybe last season or last season I came master.